Hi YouTube, this is Vector. In this video I'm going to cover the new components that I'm planning to install into my first water-cooled rig. The name of my rig is Red Engine. Basically I will install a draining system into it, a graphics card backplate, and also make some changes to my CPU water block. I will show you also the installation process of those components. But just before that, I wanted to give you a small overview of the system as it's actually designed. So okay, the case is the NZXT Switch A10, the wide edition. I chose this case because it looks great in my opinion, and I think it is also a good case to start building water-cooled system. I mean, as it's a modular case, you can choose different installation spots for your components. For instance, you can fit a 360 or a 420 watt in the top, a 120 or 140 or 240 or 280 in the bottom or in the front. And it's a good thing when you are a beginner as me, because you know, I think when you start your build you may have different setups in mind, and for some reasons a specific setup that you plan does not work, so you can have an alternative to it by changing the mounting location of your water cooling components. Okay, the motherboard is the Rampage 4 Extreme. I chose this motherboard because I'm a great fan of Asus products, and I wanted also something high quality for my system. As the color scheme I wanted for my system is black, red and white, I think this motherboard was the good choice for me because it matches this color scheme. The CPU is the Intel Core i7-3930K. I have it overclocked to 4.4 GHz, nothing major because I'm working with the system. I'm developing software with it, so I wanted something silent, and I overclocked my CPU as long as I don't get a noisy system, and at this frequency my system is very silent, almost inaudible, so this is something I really needed to work with. The memory is the Corsair Vengeance Red Edition, 1600 MHz, CL7, 1.5 volt, and I have a kit of 16 GB. I choose also this memory for the look because I think it looks awesome in combination with the Rampage 4 Extreme. The graphics card that I'm using is the Zotac GTX 680 4GB edition, reference design and reference clocks, but I overclocked the GPU clock to 1200 MHz, the memory to 1627 MHz, and the boost is 1257 MHz. The power supply is the Corsair AX1200. I know you guys will tell me that it's a complete overkill, but since I'm planning to add more graphics cards, I think this will make sense in the future. I have also a Vertex 4 128GB SSD for the boot drive, and Western Digital Green 1TB for the storage. Okay, now for the water cooling components. The CPU water block is the IKE Supremacy. It's the nickel plexi version. It has the new CSQ design, which looks very good with the frosted top plexi. The GPU water block is also an IKE. This is the IKE FC680 GTX CSQ. It's the nickel plexi version as well. For the rads, I have a Swiftech MCR 320 XP in the top. It's a 360 rad and it has a 20 fpi and it's 37mm thick. And at the bottom I have a Nikkei rad XTX 120. It has 11 fpi and it's 64mm thick. The pump is a Swiftech, also an FCP 35X with an IKE pump top. It's the IKE DDC X-Top CSQ Plexi, which matches with the Supremacy water block. The reservoir is an IKE multi-option res ×2, 250 advanced. This reservoir has many different inlet and outlet options, and you know, as I mentioned previously, when you start it's always better to select components that allows you to have different mounting options. I used Tygon tubing, the R3603 version. It's a clear one. It has an ½ inch inside diameter and a 3/4 inch outside diameter. And as coolant, I used premixed coolant, the IKE E-Coolant Blood Red. For the fan, I have 3 noise broker, the NB Multiframe S series. It's a premium fan. The model is M12S3HS. It's a 120mm fan. It has 25mm thick. 1800 RPM, 27 decibels. It has 73 CFM, which is great for a 120mm fan. And I have also 3 Xigmatech CLF F1252 LED. Those ones have 1500 RPM and 61 CFM. I installed them in a push-pull configuration for the 360 rad. I have also one other noise blocker, the same model as before, so the M12S3HS, in a push configuration for the 120 EK rad. The fittings that I used are both EK fittings and Alpha-Cool silver fittings. Okay, now for a quick look to the tubing routing. So okay, it's starting from the reservoir, 90-degree fittings, another 90-degree fittings inside the pump, then outside the pump, 90-degree fittings, small piece of tubing, 2 90-degree fittings inside the first rad, the EK one, then a 45-degree fittings outside the rad to the graphics card. I use a combination of 45 and 90 degrees for the inlet and the same as the outlet. Then into the CPU water block, straight compression fittings. Then a 45-degree out of the CPU water block to the second rad, the SwiftTech 360, and then out of the rad back into the reservoir. Okay, I wanted to give you a small explanation about the tubing routing I used. As you have seen, the coolant reached the GPU before the CPU water block, and people may think that is a bad idea because the CPU will get a higher temperature since the coolant will be warmer after it passes the GPU. But from what I have noticed so far, the water block order is not that much critical as long as you have a decent flow and a decent reservoir capacity. And you'll see that it's the case when I refill the loop. It's only a matter of a couple of degrees. So I wanted to have the shortest and the cleanest route possible. I didn't want to have, a long piece of tubing going back across the case to reach the 360 rad, which means that, I would almost double the size of the loop anyway. So I think this design looks clean, and the aesthetics for me, it's also a critical point. Now for a quick look to the part that I will install. As I mentioned, I will install a graphics card backplate. So it's the EK FC680 GTX backplate. It comes with mounting components. It's the black version. Let's just take a look. It has the new CSQ design, so this will match with my GPU and CPU water block. This backplate is also used to cool the VRM of the graphics card, but I don't think it will be better than the water block. The nice EK logo on the right hand side. For the draining system, I will use 2 Alpha-Cool multi-block fittings. It has 3 1/4 inch thread. It's the silver version. I have also a couple of EK fittings and 2 valves. It has also 2 1/4 inch thread. And then I have finally a whole bunch of pit sporer caps, the silver version. Okay, now I will drain the system, so let's take a look at it. Okay, as you can see, the system has been drained. I use plastic to protect my power supply. Basically, I just needed to remove the tubing at the outlet of the bottom rod, but with the draining system I think it will be more clean. Okay, so now I can go further and make some changes to my CPU water block. Stay tuned. Okay, so the changes that I wanted to do to my CPU water block is to replace the universal jet bed installed by default by the one optimized for socket 2011. So this is what I'm doing now. Just be careful to place the O-ring correctly in order to avoid leaks. Okay, so this is placed. I will now install the graphics card's backplate. Okay, I've placed the thermal pads onto the graphics card backplate. Now you just have to line up the backplates onto the graphics card. Included with the GPU water block package, you have an LN keyboard that you have to place at this position. Do not tighten too hard because it could damage the backplate thread and also the PCB of your graphics card. And then you will have to put 3 screws to secure the backplate using a plastic washer. The plastic washer is included with the graphics card water block package. The first one has to be placed off the right hand side of the graphics card. You maybe will notice that I forgot to place the third screw, but don't worry, I've noticed that when I watched the video, so I've placed it correctly, so don't worry. Looking awesome. Okay, so the drowning system is installed, as you can see. Basically, I've installed 2 drowning systems at 2 different locations. One to drain the reservoir side, and the other to drain the rest of the loop. So it's very easy to use. You just have to remove the caps, put a barb, and put the tubing on, and then open the valve. Nice and clean. Okay, now for the rest of the tubing. Okay, I've done the tubing now. Nothing's really changed from the setup that I've done before, except just one thing. I've done a big mistake when I first designed my loop because the inlet of the CPU water block was on the right hand side, and it has to be on the left hand side to be more accurate, to be more performant. So this is something that I fixed now, as you can see. Let's see it, we have better temperature. Okay, now the system is ready for filling and bleeding. So let's start to fill the loop. In order to fill the loop, the best practice is to have everything poured down, except for the pump, which will be plugged into a jump-started external power supply, as you can see here. To fill the loop, I use a syringe with a small piece of tubing, because I think it's the safest way to proceed, and give also more precision in the process of filling the loop. Okay, I'm starting to fill the loop. With the syringe and this small piece of tubing, it's very safe and easy, as you can see. However, it will take more time to proceed, but in my opinion, it's not a matter to take your time to fill the loop. Better be safe than sorry. Doctor, I need blood. I have a tube inside the reservoir, so it's normal that you don't see the level of coolant going up because it's filling the bottom radiator and the other component. Okay, I skipped a little bit the process because it would be too long. As you can see, the CPU water block is about to be filled. The GPU water block is already filled. So now it's time to power up the pump for the first time. Put your finger on the fill port to avoid backsplash. As you can see, the MCP35X is a very powerful little pump. No leaks, so far so good. It's important that you check for leaks every time you power up the pump. The CPU water block is filled now. Ready for a second try. Still no leaks. I think we will have a full circulation at the third try. Let's see if it's the case. Yep, we have full circulation now. Okay, the system is completely filled now. So let's go for 2-hour leak test. But just before a quick look, I think the aesthetics is completely awesome. I'm happy with that configuration. Okay, leak test done. No leaks at all. I removed the paper tails. Everything is perfect. Now for a final look at the configuration. The system is up and running now. Everything is absolutely fine. I plan to do other videos. The next one will be the installation of the EK water block for the Rampage 4 Extreme. I will also increase my pump and reservoir capacity. So thanks for watching this video. I hope you enjoyed it. If so, please like and favorite, and stay tuned if you want to know more.